By using a UniFi gateway, you can easily set up one-to-one NAT so that from internet, your clients can access your servers which are hosted behind your router. Or you can rely on the regular many-to-one NAT. Then you configure port forwarding. You can achieve similar effect. However, there is a very special situation. It is from your LAN client. If you try to use your public IP address to access your LAN server, whether it will still work. You may be surprised. In some situations, it won't work out of the box. You need additional configurations. In this video, we are going to discuss an interesting topic. It's called Hairpin NAT. Because the LAN client is using the public IP address, so the traffic seems need to go to the internet, right? However, the gateway need to make sure the traffic in fact go this way, go back to the internal network, go to the LAN server. So these red links are like a U-turn. That's where the hairpin NAT gets its name. It's like a hairpin. So in this video, we are going to explore 4 different scenarios. First, you have the regular many-to-one NAT. Your LAN client is in different VLAN than your LAN server. The second scenario, the LAN client is in the same VLAN as the LAN server. The third scenario, you configured one-to-one NAT. And what if your LAN client is in different VLAN than the LAN server? The very last scenario, you are still using one-to-one NAT, but the LAN client is in the same VLAN as the LAN server. Okay, we have a lot of things to discuss. Let's get started. First scenario, you can see in UniFi network application, I have default network and the VLAN 10 configured. Then if I go to policy engine for NAT rules, you can see I only have the 2 masquerade rules active. They are the default ones for the 2 WAN ports. In this video, I'm only going to use the primary WAN port for all the testing. So only the first masquerade rule will be relevant. And if you go to the internet setting for primary WAN port, you can see I have the main IP address configured. Keep in mind, this is my lab environment. That's why for the one IP address, you still see private IP, right? It doesn't matter. It works in the same way, regardless whether your WAN port is private or public IP address. Then you can see I do have additional IP address configured for the primary WAN port, but they are not relevant to this video. Then go back to policy engine. For port forwarding, at this moment, I do not have any port forwarding configured. Everything is default, right? Then in the lower part screen, I show you 3 Linux machines. The first one is the LAN server. If I run the curl command against itself, you can see I can successfully retrieve the homepage for the web server, which is running in this LAN server. Okay, and then in the second Linux machine, it is running from the outside of this gateway, from the WAN part. If I try to access the primary WAN port's IP address of the UniFi gateway, as noted in the diagram, it will fail for sure because we haven't enabled port forwarding. The WAN client cannot really access the service, right? Then go to the right side LAN client, which is running in default network, not the same VLAN as the LAN server. If I try the same command as the WAN client, see here, I'm trying to access the WAN port IP address, not the internal private IP address of the LAN server, because that's the point of this video. We want to see whether we need hairpin NAT to enable this type of access, right? So let me run it. It cannot connect as expected because we haven't enabled port forwarding yet. As we already checked, we already have the default masquerade rules which enable the internet access from the LAN, right? The only thing we are missing to achieve the effect that the LAN server can provide service to the outside world is a port forwarding. So let me go to the UniFi network application, go to port forwarding. In fact, I already have this one created, but now it's inactive. So let me activate it. Okay, then we can check what it is doing. This is a port forwarding rule. It works on the primary one port, and the one IP address is the main IP address, which is 18.101. And I only want to forward port 80 to what? To this LAN server. This is the VLAN 10 IP address for the LAN server, and forward to the exact same port 80. I only want to support TCP because this is a web server. Okay, that's it. So with this enabled, now let me repeat the testing from the one client and the LAN client. At the same time, I'm going to run Wireshark packet capturing inside the UniFi gateway so that we can see whether the address translation happens or not. I have launched a Wireshark. I'm going to use SSH remote capture. I will log on to the gateway itself. Then I will capture all the remote interfaces. I will apply a capture filter for port 80 so that we can capture the HTTP packets. So the reason I use SSH remote capture is I want to see not only the traffic on the LAN, on the WAN, but also inside the UniFi gateway among the multiple internal interfaces. Only in that way I can tell whether an address translation happens or not. Okay, so let me start it. Now from the one client, let me run the exact same curl command again. Okay, it's successful, right? Stop capturing. Let's examine what happened. First packet related to our testing is this one. So you can see it's from the one client IP address .18.something. It's connecting to the one port IP address of the UniFi gateway. See the next packet? What's the difference? The destination IP address was translated from the one port IP address to the LAN server IP address. This is where the NAT happens. And see the column for interface index. The first packet is 3, the second packet is 22. So to understand what they are, in the lower part Linux terminal, I already SSH to the UniFi gateway. Then let me run IP link. From this output, we can easily tell what the numbers are. For example, number 3 is Ethernet 2, which is the primary one port for the UX3 Pro. It makes sense because the first packet was intended to be sent to the one port. See the next packet, interface 22 is here. BR10 is the Linux bridge for VLAN 10. So that also makes sense because after finishing the NAT to translate the destination IP address, the packet was sent to the VLAN 10. I don't want to waste your time explaining the remaining part. That's just regular HTTP traffic. Just from the first two packets, we can already tell, yes, the NAT happened. Where the NAT comes from is due to our port forwarding. You may know, technically, port forwarding is implemented by using DNAT, right? So only after we create that port forwarding, this NAT can be possible. So we are good with the one client, which is completely expected, and that's how port forwarding is supposed to work. So then let's move on to the LAN client. This is the interesting part because normally when we say port forwarding, we mainly think about the clients from the internet. But this time we are using a client inside your LAN. So let me restart the packet capturing. You can ignore whatever happened. They have nothing to do with our testing. From this LAN client, let me rerun the previously failed curl command. Okay, it's successful from the client. Interesting. Stop capturing. Starting from this packet is sent from this LAN client because I can tell from the source IP address, right? .50.88. That's my default network. Then it's sent to the primary one port. That also makes sense. And the interface is 5. In the SSH session, we can tell 5 is the LAN port. That also makes sense. Then see the next one. It seems the source and the destination, they are identical. However, the interface is different. It's 15. So let's see what's 15. 15 is BR0. That's the bridge for default network. It also makes sense. Then continue looking. See the third packet. The source IP address is still the LAN client, but the destination was changed. It's changed to the LAN server. This is where the address translation happened. And see the interface is 22. In the SSH, we can see the 22 is BR10, the bridge for VLAN 10. Why VLAN 10? Because the LAN server is in VLAN 10. Something happened so that the second packet's destination was translated. Instead of saying the WAN part, now it's pointing to the LAN server. So we need to understand what happened here. In the lower part SSH session, I'm already in the UXG Pro. Let me show you the IP tables, NAT table. Without going to this type of details, there's no way for us to understand how the traffic goes just by checking the web UI. Okay, run it. So this chain post routing is for our SNAT and masquerade NAT. You can find two masquerade NAT here. The first one is the regular masquerade NAT, which is related to how one client can access the LAN server. The second masquerade NAT is related to next scenario. Neither of these two masquerade NATs has anything to do with our LAN client for this scenario. And if you continue looking, there's another chain is pre-routing. It's for DNAT. So you can find this DNAT rule. This is the result of our port forwarding. So you can see as long as the destination IP address is within this IP set, in the interest of time, I won't show you what's inside this IP set, but basically it's the one part IP address. So what this DNAT rule is saying is, as long as your destination is the one part IP address, and if your destination port number is 80, it will do the translation, translate to the local LAN server. If you compare this internal DNAT rule with our port forwarding on the UI, you may realize some seemingly different thing. On the UI, when you define a port forwarding, you need to indicate the WAN interface. So you may think the WAN interface will be a condition for a packet to meet so that the DNAT rule can be effective, right? But in fact, if you check the DNAT rule, it has nothing to do with the WAN part. In fact, on the UI, you need to select a WAN interface. The only reason is, based on your selection, the system can automatically prompt you the IP address. That's it. The reason I want to highlight this point is, you may think the DNAT rule or the port forwarding only applies to the WAN traffic. No, it's not the case. If you read this DNAT rule, you can see it applies to whatever interfaces, as long as your destination IP address is the one part IP address and it's 80, the DNAT rule will apply. Because of this DNAT rule, our traffic from the LAN client also meet all the conditions. The destination IP address will be translated. So that's why if we go back to Wireshark, see the third packet, the destination IP address was translated from the one part IP address to the LAN server, right? Now we understand why the destination IP address was changed, right? And then let's see another dramatic change. It's about the interface. The second packet, the interface was 15, which is bridge 0 for VLAN default, right? Then the third packet has interface 22, which is bridge 10. Because of the bridge was changed from default network to VLAN 10, that means routing happens. That's crucial because the LAN client is in default network. For the LAN client to reach out to the LAN server, which is in different VLAN, routing must happen. But the routing happened for this case because the DNAT rule translate the destination IP address from the one IP address to the LAN server, which makes the routing possible or necessary. So basically, from the second packet to the third packet, two crucial things happened. First, DNAT, then routing. Go back to the NAT table. So in the whole process, you can see neither of the masquerade rules was effective. These masquerade rules have nothing to do with this scenario. For the LAN client to be able to connect to LAN server. For this particular scenario, you don't need to create any manual NAT rules for Hairpin NAT. Just the default port forwarding is enough. I hope it's clear about this particular scenario. Let's move on. What if this LAN server and the LAN clients, they are in the same VLAN? I have already changed the LAN client to VLAN 10. We can confirm by checking its IP address. It's in VLAN 10. Then in Wireshark, restart capturing. Then from the LAN client, let me run the same command, curl the primary one part's IP address. Interesting. This testing is also successful. So let's try to understand what happened. Starting from this first packet from the LAN client sent to the one IP address, right? Then the second packet seemingly identical, but the interface was changed from 20 to 22. If we check the SSH session, it was changed from VLAN 10 interface of the LAN part to bridge 10. That makes sense. Then see the third packet. It is still the same bridge 10 interface. However, what are the big changes? Both the source and the destination IP addresses were changed. This is huge. Let's investigate what really happened. For the destination IP address, it's changed from one part IP address to the LAN server. This should be due to the DNAT rule, right? However, why the source IP address was changed? So see, it's changed from the LAN client IP address to the gateway IP address for VLAN 10. What's going on? So to understand what really happened, again, we have to go to the backend to look into the NAT table. In the SSH session, let me show you the IP tables, NAT table again. Remember, in the first scenario, we said these two masquerade rules are not involved in the process. This time, the situation is different. See the second masquerade rule. In first scenario, the packet count here was 0. Now it's 1. Why is 1? Because we just did a successful testing from the LAN client. So which confirms this masquerade rule was part of the scenario 2's process. So let's see what's this masquerade rule at all. It applies to TCP and only if the destination is Debian. Debian in this case meaning the LAN server because it has the local host name Debian. But just to confirm, let me exit this command, then run the command with -n as parameter so that we can see number instead of the domain name. Okay, now it's clearer, right? As long as the destination is this IP address, which is the LAN server IP address, and if the source matches this IP set. In the interest of time, I won't show you the details of this IP set, but just by the name, you can already guess it's for the subnet of VLAN 10. So which means for our case, the LAN client's IP address fulfills this condition. In our testing, our destination part is 80. Our testing scenario completely meet the condition for this particular masquerade rule. That's why this applies. So let's see what's the end result of this masquerade rule. You may know the masquerade rule is a special SNAT rule. So it will change the source IP address to the gateway IP address. But here, what's the gateway IP address? Because we are talking about the source packet from this IP address. And if we check the Wireshark result, the original interface was 22, which is BR10, the bridge for VLAN 10. So the gateway IP address for VLAN 10 is .10.1. That's why here, see the third packet, the source IP address was translated to .10.1. That's the result of this masquerade rule. So let's go back to this third packet, which is crucial in this process. So the destination IP address was translated to the LAN server because of the DNAT rule, because of the port forwarding, right? Then the source IP address was translated to the gateway IP address because of this masquerade rule. However, you may ask where this masquerade rule even comes from, because if we check the masquerade rules on the UI, we can only find the default masquerade rules, which is for the one part. This one you are seeing on the screen is corresponding to the first masquerade rule. It has nothing to do with this one. You know what? The second masquerade rule is the result of the port forwarding rule. So the system created this masquerade rule exactly to resolve this type of situation. If you have a client from the same VLAN of the server, if you try to access the one part IP address, the system can correctly direct your traffic to the correct server. This is the Hairpin NAT we have been talking about. So the system automatically created this Hairpin NAT rule, which is a masquerade rule. Okay, just to confirm, this masquerade rule is the result of the port forwarding. Let me go to UniFi network application. For this port forwarding, let me pause it. Then let me exit the editor, run the exact same command again. See what's changed? In the post routing chain, we only have one masquerade rule left. It is the default masquerade rule for the one part. Our hairpin NAT masquerade rule is gone because we disabled the port forwarding. Okay, I hope now it's clear, right? So to resolve this scenario, yes, you do need a dedicated hairpin NAT, which is a masquerade NAT, but you don't need to manually implement it. The system does it automatically behind the screen. So we are good with this scenario. Let's move on. The third scenario, if you implement one-to-one NAT instead of the default many-to-one NAT, then if your LAN client is in different VLAN than the LAN server, whether it will work. In this video, I will not discuss the details about one-to-one NAT. If you are interested, you can watch my separate video about one-to-one NAT. I'm directly going to network settings. For NAT rules, let me enable the two one-to-one NATs which I already defined, but now they are inactive, a DNAT rule and a SNAT rule. Resume them. Done. So then let me launch a Wireshark session to capture the packets in the same way. Then let me go to the WAN client. Let's validate in this initial one-to-one NAT scenario whether the WAN client can access the LAN server by using this .102 external IP address. So in the WAN client, let me run curl command. I want to use the WAN IP address which is used for the one-to-one NAT. So let me run it. Okay, it's successful. Then something's captured. Let me stop capturing. Okay, the first packet starts from here. So from this one client, it's trying to access .18.102, and then immediately in the second packet, the destination IP address was translated to the LAN server IP address. Why is that? It's because of our one-to-one NAT. The DNAT rule did this translation. This is expected. This is how one-to-one NAT works. Okay, then the remaining packets were just normal packets. Nothing special about this one client. Then let's quickly move to the LAN client. Now the LAN client is in a different VLAN than the LAN server. We can validate it by checking the IP address. It's in the subnet for default network. So then let me start Wireshark capturing from the LAN client. Let me run the curl command, this time against the .102.1 IP address. Let's see whether it can reach out to the LAN server in this way. Okay, it's failed. Let's try to understand what happened from the Wireshark. See the packet starting from this one. From this LAN client, it's trying to reach out to the one IP address. And then the next one, the same source and destination, but the interface was changed. From the IP link result for UX3 Pro, you can see the interface was changed from 5, which is the LAN part, to 15, which is the bridge for default network. It makes sense, right? Then you see the next two, they are in red color because the system doesn't know how to route the second packet. Why is that? Because in the second packet, the source is in .50 subnet. The destination is the one IP address. Let's try to understand why the one-to-one NAT rules we created won't help us in this scenario. We have two one-to-one NAT related rules. First one, the DNAT. So you can see what it really does is if you try to access the one part IP address through the primary one part, your destination IP address will be translated to the LAN server. So this is the DNAT, which represents this direction from outside to inside, right? Then let's check the SNAT. The SNAT rule says if the source is the LAN server, it has a traffic through the primary one part, meaning if it wants to communicate with internet, then its source IP address will be translated to the one part IP address. Apparently, this SNAT also doesn't apply to our LAN client traffic, which means neither of the DNAT and the SNAT rule which we created for the one one-to-one NAT applies to this LAN client traffic. So that means no NAT will happen for the testing we just did. Then of course the system doesn't know how to deal with this packet. Here some people may say, hold on a second, what do you mean there's no NAT will help? We do have a default masquerade NAT, right? This one is for internet access for LAN client, and because the LAN client was trying to access the one part IP address, that's internet, right? Why this NAT rule didn't help? So let me explain that. Yes, the destination IP address is the one part IP address, but it doesn't mean the masquerade rule here will apply. The reason is this IP address is special. It is the gateway's own IP address. So from IP table perspective, if the traffic is going out or going to other VLAN, which means if it need to be routed, then your traffic will go through this post routing chain. The masquerade rule is in the post routing, right? However, for this special case, the LAN client is trying to access the one part IP address only. The one part IP address is the gateway's own IP address. That means the system doesn't need to do routing, which means this post routing chain will not be executed. Instead, the chain the system will execute is the input chain. However, let's see what's inside the input chain. The input chain is the input jump. See what's inside the input jump? Nothing. So to put another way, if a LAN client directly access the one part IP address, it's very easy because everything happens inside the gateway. No routing is needed, right? That's why you don't see any NAT rule here. However, just because of the same reason, our testing failed. So we need to do something. To resolve the issue, we need to create new NAT rules. I have already created the NAT rule which is required. So let me simply enable it. Then we can check what's defined there. So this is a DNAT rule. What I'm saying is if the traffic is through the interface for default network, and if the source is from default network, and the destination is the one part IP address, I will translate the destination to the LAN server. This DNAT rule is tailored for our scenario. If the LAN client try to access this IP address for one part, it will be translated to the LAN server. That's the DNAT rule for. So we don't need a SNAT for this testing scenario. Then from the LAN client, let me repeat the testing, curl the one part IP address. Okay, see, it works now. I won't show you the Wireshark capturing. You may be tired of that level of details already. It works in a similar way as previous scenario. Okay, so now let me advance to the very last scenario. So you still have one-to-one NAT, but this time your LAN client exists in the same VLAN as the LAN server. So let me quickly change the VLAN for the LAN client. Okay, VLAN is changed. Let's validate the IP address. You can see it's in VLAN 10, the same VLAN as the LAN server, right? Now without any change in our NAT rules, if I try to curl the one part IP address, see, it failed. To resolve the issue, we need to do two things. First, just like in previous scenario, we need a DNAT for the VLAN 10 client. But it's not enough. Like the scenario 2, in the M21 NAT scenario, we need a special hairpin SNAT because the LAN client and the LAN server are in the same VLAN. So let me activate these two NAT rules, which I already created. Then we can go through them. Let's look at the DNAT rule first. It's very simple, defined in the exact same way as previous scenario. It's a DNAT rule. If the source IP address is from VLAN 10, if the destination is the primary one part IP address, and if the traffic is going through VLAN 10 interface, I will translate the destination to the LAN server. Right? Very easy to understand. But let's check this hairpin SNAT. What it need to resolve is the exact same situation as scenario 2. When the LAN client and the LAN server is in the same VLAN, we need a very tricky SNAT rule to translate the source IP address to the gateway IP address. So this is what it does. If the source is from VLAN 10, if the destination is the LAN server, and if the interface is the VLAN 10 interface, it will translate the source IP address to the gateway IP address. So in scenario 2, the system implemented using a masquerade rule. And in this example, I implemented using a SNAT rule. They do the same thing, the tricky SNAT translate. Okay, so after we have these two NAT rules active, then let me redo the testing from the LAN client, curl the same IP address. Now it works. Okay, we already finished all the scenarios, so let me summarize. In the M21 NAT setup, which is default for UniFi gateway, when the LAN client is in different VLAN as the LAN server, you don't need to do anything, and there is nothing special needed. Just the DNAT rule, which is the result of port forwarding, is enough. But if your LAN client is in the same VLAN as LAN server, you rely on a Hairpin NAT to do the translation about source network. Fortunately, UniFi Gateway implement an extra masquerade rule to do this job automatically, so you don't need to do anything. That's part of the port forwarding internal implementation. But for one-to-one NAT, because the system doesn't have the direct setting, you have to implement one-to-one NAT by yourself. That's why you may need extra work. So if your LAN client is in different VLAN than the LAN server, you only need a new DNAT so that you can translate the destination IP address. However, if your LAN client is in the same VLAN as the LAN server, you need a special Hairpin SNAT to translate the source IP address as well. Okay, this ends the video. Thanks for watching.